Hi, in this video we're going to discuss about chain drive and rope drive. So previously in the class we already discussed about the belt drives, that is the flat belt drives and the V-belt drives. So coming to chain drive, chain is used to transfer the motion from one shaft to another shaft with the help of sprockets. So it is a drive that maintains a positive speed ratio between the driving and the driven components. So the tension on the slack side is considered as zero. So they are generally used to transmit the power in the cycles, motor vehicles, agricultural machines and rollers, etc. So what are the merits you're going to get? So the merits will be chain drive or positive drive, so there won't be any slippage. So they are highly efficient when operating under the ideal condition. Can be used for both relatively long or short center distances, whereas the belt drives, some flat belt drives can be used for longer distance, and for short distance we are using the V belts. So less load on the shaft and the design will be compact. So coming to demerits, so it is high production cost and noisy operation, and maintenance and servicing requires more cost. So we know that the servicing of the chain, it takes the maintenance and servicing will be taking a more cost for the chain drives. Coming on to different types, so the first type will be the block chain, roller chain and inverted tooth chain or a silent chain. So when you go for the roller chain, you can see in the diagram, so these are the rollers, so it will be supporting the complete chain links. So the inner link plate and outer link plate, and there will be pins which will be just like an riveting, and you can see the pitch between the two rollers. So when you go for inverted tooth, so this is the inverted tooth where you can see the pin, the bushing and the pitch between the two teeth. So coming into the velocity ratio in chain drive, so velocity ratio will be N1 by N2 is equals to Z2 by Z1, where N1 will be the speed of a driven sprocket and N2 will be the speed of the driven sprocket. So Z1 number of teeth on the driver and N2 will be the number of teeth on the driven. So coming to the design procedure, first we'll see the nomenclature, what are the things you're going to get. So P will be the pitch and D1 will be the diameter of the smaller sprocket and D2 will be the diameter of the larger sprocket. N1 or speed of the smaller, N2 the speed of the longer sprocket. When you go for Z1 and Z2, Z1 will be the number of teeth on the smaller one, Z2 will be the number of teeth on the bigger one. L will be the length of the chain. So the length of the chain can be in terms of mm or in terms of pitch. When you go for LP, it will be length of chain in the pitch. C will be the center distance between the two shafts or the two sprockets, and CP will be the center distance in terms of pitch. And FU will be the ultimate or a breaking load. So FT will be the required chain pull and FA will be the allowable pull. And N0 will be the working factor of safety and NA will be the allowable factor of safety, and V will be the velocity at which the drive will be driving the shaft. So the design process start with the pitch of the chain. So first we need to find out the pitch. So they are based on the RPM from the smaller sprocket. You can find the pitch. So the formula will be 21.106 C. So P is less than or equal to 25 multiplied by 900 by N1 all to the power of 2 by 3. So once you got P value over here, so go for the table number 21.64. Select the nearest value for the take what is the answer you got from P, so that you're going to select. So from that table you're going to select the chain number, braking load FU and measuring load W. So these are three things you can get from the table 21.64. So next step will be number of teeth on the sprocket. So you have to find out the number of teeth on the sprocket. So first you have to get the value of any Z1 or Z2. So from the table 21.60 for a given N1 by N2 ratio, so select Z1. So Z1 once you selected, you can find Z2 from the equation. N1 by N2 is equals to Z2 by Z1. So the third step will be pitch diameter. So we have a formula, D is equals to P, that is P pitch divided by sine 180 by Z. So equation number 21.126. So Z you can replace with Z1 and Z2 so that you can find out D1 and D2. So diameter of the smaller sprocket and diameter of the larger sprocket you can find out using this formula. So once you find out the pitch diameter, go for the velocity. So velocity is given by P Z1 N1 by 60,000 meter per second. So equation number 21.105. So where P will be in terms of mm. So I am going to substitute the values. So P, Z1 value I am going to substitute, N1 I am going to substitute. So I am going to get the velocity V. So once the velocity is found out, I have to find out the required pull. So for that we have a formula, the power required, that is N is equals to F theta V divided by 1000 KL and KS. So the equation number will be 21.115A. So here N will be the power, so that will be given in the problem, or you can calculate F theta will be the required pull, so V will be the velocity, KL will be the load factor, and KS will be the service factor. To get the load factor, either you can assume between 1.1 to 1.5, that is one option. The second option will be from the table 14.4, you can get the KL value based on the condition they given in the problem. The next one will be KS, that is the service factor. So you can get from the table 21.61. So you can identify the KS value. So once you got all the values, substitute over here and find the F theta. Allowable pull, that is FA is equals to FU by N naught. So working factor of safety you can take from the table 21.75. So from the question you can identify the condition. You can take the working factor of safety. So FA is equals to FU by N naught. So FU already taken from the table. So that you can substitute and you are going to get the value. So number of strands in a chain. So what will be the number of strands in a chain? That I can identify by I is equals to F theta by FA. So the equation number will be 21.118. So coming on to check for the actual factor of safety. So FU is equals to NA is equals to FU by F theta, FCS and Fs. So the into I will be the number of strands. So the equation number 21.117. So when you go for the equation, so F theta you can calculate. F theta is equals to 1000 N by V. So N will be the power and V will be the velocity. FCS, that is the tension, the centrifugal tension. So that you can find out by W V square by G. Fs, that is the tension due to the sag in the chain. So KSG W into C. If C is not given, you can assume CP in terms of pitch. CP is equals to 30 to 50. So 30P into 30P to 50P. So KSG, the coefficient of sag, can be taken from the table, that is 21.58 table. So once you substitute all the values over here, so I am going to get NA, that is the actual factor of safety. If actual factor of safety is greater than allowable, so then the design will be the safer one. So next I have to find the length of the chain in the pitches. So LP is equals to 2CP cos alpha plus Z2 plus Z1 by 2 plus alpha Z2 minus Z1 by 180. The equation number will be 21.122. So here I can find the length of the chain in terms of pitches. So where alpha can be calculated using the formula, alpha is equal to sin inverse D2 minus D1 by 2C. So C is nothing but the center distance over here. So once the length is find out, so length of the chain I have to go for. So length will be equals to pitch into length of the chain in the pitches. So I want to get that the length in terms of mm. So that is the equation number 21.125. So the last step will be the correct center distance. So I am going to go for equation LP is equals to 2C by P cos alpha plus Z2 plus Z1 by 2 plus alpha into Z2 minus Z1 by 180. So from this I can find out what is the correct distance of the center. So these are the procedure you are going to follow for designing a chain drive. So next video you are going to see about the problems.